Well, I hope that that last little bit of the video there, the last video, made somewhat sense, but in case it didn't, I'm going to go ahead and do this really fast, all right? So I have to come back here to my constraint that I made, and I got rid of the contact, so I'm going to go ahead and do that. Maybe I'll leave it. How about that? It'll be easier to see what I'm doing, okay? I still have the two coincidences, the edges. I can't remember which one, cross corners, one of the two of them that are lined up from here to here, okay? It's there and there. So here's what's going to happen. We realize that there was a mistake and we have to make a modification. So I come back over to my part here. And this feature here, oops, get off of there, compass. I need to go to that. And this gap distance here, it was just too big. The part didn't fit. So I'm going to take this over here and I'm going to change this one. I'll make it a little bit dramatic. I'll say full other direction. So I want to make it 6. So it's from the edge, right? So that's going to skinny it up. Then this one's 6 also. Later, we'll look at ways to actually link things like this together, because if they always are 6, then I can just change one and everything will change. Okay, so we exit out of here. And then let's go back to this and see what's going on. Okay, so I come over here and I have my constraints, but see if I can show you this here. You know, if I were to look straight down on it, they're not over the top of each other. So I go over here to engineering connections and I say update. And here's what I get. So first off, it didn't exactly jump out and tell you that there was a problem, okay? So remember a few videos back when I showed you what that little red dot means, and I said it really isn't quite important for what we were doing at the time, but it's a red thing and it might draw your attention. That is a sign saying it needs to be updated, okay? And if you look down here, there's a thing that says update as well. And it's got a little red X on it because this thing popped out. So you would notice the little red dot, and so then you maybe develop a habit to go over and say, ooh, red dot, let's go update it. And then when you updated it, you would realize, or it would come up with an error saying, something is wrong. It's not going to work out, okay? So in this particular case, it's saying that that constraint that we have is not going to work. But I did notice that it moved. So it is one of these coincidences is okay, but the other one it discounted. So rather than fix this, because you know there's nothing I can do to fix this other than make it larger or pick something else to constrain it to, well, we're going to do that. We're going to come up with something else to constrain it to so I can get this thing to update. If you see this down here like this, that's a problem. You have to know to recognize that. So let's move on with our little lab here. I'm going to entirely delete this constraint right there. And notice our update is good. And if you hit the button, boop, boop, that little window comes up. It updated just fine. Okay, so this is a topic about assembly connector points. This is not, you know, a name that you're going to find in a textbook. It's just something that we call this. So if I have two parts of an assembly and I have some way to connect them together, like this face to this face, that's great. If I happen to have, a nice little point and there's a nice little cavity down here and I can match point to point, you bet, absolutely do it. But if you don't, then you make one. So what I would like to have happen is I would like to have the center of this surface be equal to something, let's say on the center of this surface, some point to a point here. I want to tell it where to constrain. So here's what we do. We go over here to the top draft and I will double click on any one of these things here, the part body, get into that. And again, for clarity, if you want to hide the other one, if it helps you understand where you're at, that's fine. So here I am in part design. I look over here, make sure that the last thing in the tree is underlined. If it's not, remember this, define in work object. There's the underline, back in time, right here. Define in work object, There it is, but without the little part that sticks out. Right here, this last one, define in work object. The sketch is it's the parent of pad 2. This is not the last thing in the tree. It goes from this branch right here, down, down, down. So the pad 2, that's the last thing. Okay. So now that we're there, I'm going to pick the bottom of this and I'm going to go into sketch. And here is simply all I need to do. Well, in this particular case, I could take a point and I could stick it right there. I could put a point right in the center. And notice, this is what they call a standard point. We looked at this before. There's a standard point. We don't want it to be construction element. If I exit out of Sketcher, you see that we have that point still there. Okay. That's all I'm going to do. And then I'm going to do it again a different way. Okay. So I'm finished with that one. And then I unhide this one. And I whoops, that's not going to work. Okay, so then we go over here and then double click on something like this. Make sure pocket 1 is underlined there. And then I go to that shape right there. Am I where I'm supposed to be? There it is. I don't know why my little menu wasn't popping up. So I hit this. That's in the way, so I'm going to go ahead and hide it. I'll do the same thing and I'll put a point right in the center right there. And then exit out. Okay, so I got a point there and I got a point in the other one. I'm going to double click on Draft Lab, which is the very tippy top, right? Gets us back into assembly mode. And I will hide show that one right there. And then here's what you do. That one right there, I want that touching that. So this is going to be our contact constraint. It'll serve as a contact constraint because they're going to go touch together. But then if I were to change the size of this or this wall right here, that would not change the center point, and so our constraint would still be valid. The problem, well, the issue we'll be left with is if I touch this point to this point, that will suck up some degrees of freedom, but I'll still be able to twist this around, okay? So just to show you, I'm going to put this up here and I'm going to rotate it around a little bit, right? And then we'll get rid of this. Now watch. So now I go and I'm going to pick a constraint. By the way, what type of constraint do you think we're going to use? I said contact because it's going to make the two things, the surfaces and the points are going to touch together, but it's actually not a contact that we're going to use. It's actually the same thing we've done before in Sketcher for pretty much the same purpose. Coincident. So I'm going to say that that point up here is coincidental to this point right there. Make sure you get right on the point. If you couldn't get the point, this is a little bit of another side journey here, but I could drill down in the tree and I could go to geometry and I could find the point. Oops, I think that's oh yeah, draft base, right? So I could go here and I could find this sketch right there, open that up, go to that geometry and that point right there. You see? Excellent. So now those 2 points are coincidental, but like I said, it's crooked. So how do we solve this? Well, I could come in here and could I make like that surface inside there contact this other one? No, because the inside one, this one here on the top is smaller than the other one. So that ain't going to work. How about an offset? That ain't going to work either because that distance might change if you remember how an offset works. So here's a new one. I want to make it, how about parallel, sort of, right? But I don't, here, watch this. So I hit here and I look, I have parallelism. I have an angle also. I've got these guys right here. Well, if I wanted to, I could make 2 corners perpendicular. That'd be kind of weird. But I could go with one of the 2 of these. One thing that was pretty common, if you thought that you ever wanted to turn it, but right now you wanted it to be parallel, you would make it an angle of 0. And then later, whenever you want to edit it, then you could just click on that constraint. You could change the value. So I'll come over here and I'll hit parallelism and then sneak in here. You have to get kind of used to this. Get in there. And then you pick this right here. And look at that. So now it's parallel And you can see that edge gap that we have. Now we know that, I mean, that's a big edge gap, but you know, the thing would fit nicely. And this right here is now we're beginning to get a little bit closer to the way real life would be. If you really were to manufacture something like this, we have to have this fitment tolerance. You might even have a situation where one of these is actually tapered. One of these little, like the part that sticks out of this top here, imagine we actually put a draft on that a little bit. So when you dropped it in here, it kind of wedges in place. You could totally do that. Yes to that. And there you go. So that one was a little bit longer than normal. Hopefully that makes sense. If it did not, of course, do this. This is your exercise to do, and think about it. You know, consider how this is all working, and then maybe even try to do your own a different way, and see if you can replicate all the elements that we have in here.